theorem statement is this G be a graph with n vertices, lambda 1 is a largest eigenvalue, delta G is the maximum degree, D average is a average degree of graph, and D means is a minimum degree of G. Okay, and then if these are our parameters, then this inequality is hold, like minimum degree is always lesser than average degree is lesser than lambda 1, and lambda 1 is lesser than or equal to delta of G, means maximum degree. So by this theorem we can know that this relation between degrees and our spectrum means eigenvalue, largest eigenvalue. Okay, so let us prove this all this inequality one by one. So start with first. Okay, so proof 1. Okay, so first proof for that average degree. Okay, so let us consider our ith vertex. Vertex has minimum degree, means di is equal to d mean. Okay, then we can write d average. D average is equal to d1 plus d2 plus up to dn divided by n, means sum of all degree and number divided by total number of vertices. Okay, then we replace all this degree with a smaller quantity, means di. So di is a minimum degree, so we replace this with this di. So at that time we can so if we replace this, then this is an inequality, right? So it is a di plus di plus up to di divided by n. So di is multiplicity of this sorry, not multiplicity. Okay, so di's are n time, right? Okay, so this is equal to n time di divided by n, so is equal to di, right? So hence it implies that d average is lesser than or equal to okay, and di is equal to d mean. Okay, d mean, right? So hence our first inequality is true, right? So let us prove second. Okay, so first of all, what is that inequality? D average is lesser than or equal to lambda 1, where lambda 1 is a largest eigenvalue. Okay, so lambda 1 we can write as maximum of Rayleigh quotient. The Rayleigh quotient is x transpose maximum over all x, where x transpose x and x transpose x, where x is of n dimensional vector and A is adjacency matrix, right? So let x is equal to all one vector. So this one is my all one vector, right? So let us put this value in our above equation. So lambda 1 is equal to maximum over all x x transpose Ax is equal to x transpose x. If we replace x with 1 and okay, so with particular one vector, then this quantity is always greater, right? So at the time we write 1 transpose A 1 and 1 transpose 1. Okay, so okay, so first of all let us see that what are this quantity like in denominator and numerator and denominator. Okay, so first of all what is this quantity? So this quantity is all one vector, so this quantity is n, right? And a1 will give degrees, degree vector means d1 d2 up to dn. This will give this, and if we multiply this with all one vector transpose, then it will give 1 transpose A 1, it is a sum of degree d1 plus d2 plus up to dn. Okay, so upper quantity is d1 plus d2 plus up to dn divided by n, so it means it is degree average. So from here we can write lambda 1 is always greater than or equal to degree average. So hence second proof is also true. Okay, so okay, then let us start our third proof. Okay, so third statement inequality is this: lambda 1 is always lesser than or equal to delta of g, right? Okay, so for that we know that lambda 1 is the largest eigenvalue, so lambda 1 and lambda 1 is the eigenvalue and corresponding eigenvector is v, and let ith entry of vi is largest entry in our eigenvector v. Okay, then okay, so with this parameter, okay, now consider this. Okay, now consider if we can write av is equal to lambda 1 into v. Now consider ith entry of both sides. So first of all we write ith entry of right hand side. So ith entry of right hand side is lambda 1 vi is equal to ith entry of left side, right? So it is a of v, a into v is a one vector and ith entry of that. Okay, so this we can write as summation of j is equal to 1 to n aij vj. Okay, so here we replace okay, so vj is any entry of our vector, so this one is our vector, v is equal to this v1 v2 up to vn. So vj is any entry of this vector
and somewhere it is ith entry. So ith entry is the largest entry. So we replace vi with vj, we replace vj with vi. So at that time we are replacing with larger entry, so this our next quantity is higher. So at that time summation of j is equal to 1 to n aij and vi. Okay, so now you can see that this quantity is nothing but a degree of ith vertex. So we can write degree of I into vi. So di we can replace with maximum degree, delta of g vi. So from this we get what we get, lambda 1 vi is lesser than delta of g vi. From this lambda 1 is lesser than to delta of g. So hence proof, right? Third inequality is also true. Okay, so in this proof we have seen all the relation of minimum degree, average degree and maximum degree with eigenvalue, largest eigenvalue. Thank you.